Hello guys, welcome back to my channel Maison African Motives. Still working on engineering science N2. So we have the question which is on dynamics, which is from one of the question papers, and we are given to define the following terms. Okay, so this is question number 1 on dynamics. So if you're new to my channel, you can consider subscribing so that you won't miss any of the classes that we shall be having from Maison African Motives, and also to share our videos to our friends and colleagues so that they also can benefit from this information. Okay, so quickly rushing through the question, we are given to define the following terms: velocity. Okay, so I've just here having a definition that can be proper, which is the velocity is the rate of change of displacement. Take note the displacement, which is we remember when you are given displacement, you're just talking about the distance that is being taken from a straight, maybe you're talking about a straight line and from one point to another point. So that rate of change now is now the velocity. As you can see that it's actually the change in the displacement over the change in time in actual sense, and this is measured in meters per second, which you can write in this format, or you can write like this, meters per second. So that is the information that you can actually need for velocity. And also we have acceleration, which is the rate of change of velocity now. So acceleration is rate of change of velocity. That is why we are now having acceleration as the change in velocity over the change in what? Over the change in time, which is measured in meters per square second, or it can be written in this format like that. So that is what we are having when you're working with acceleration. Okay, so let's quickly rush to the other question where we are asked to, on 1.2, the graph in fig 1 below represents the velocity time graph. Okay, we are given the velocity time graph of a train traveling at a constant velocity and then decelerating. Okay, so let's actually see what's happening here. As you can see, this is what is happening from this point to this point. This is constant velocity, which means the acceleration in this case is a 0. There is no acceleration. Then deceleration, as you can see, it's reducing in terms of what? In terms of the speed. The speed is reducing until the speed is at what? Is at 0 meters per second. So as you can see, this is velocity in meters per second. Then this is time in what? In seconds. So take note, we have velocity and we have time. Okay, so the first question is to determine. So the deceleration in this case is actually equivalent to the negative acceleration. So that is the first part that we need. So as you can see, the deceleration is from this point to this point here. So what we have is actually the negative acceleration in this case. So we shall obtain something like this, which is equivalent. Actually, this is negative acceleration. So what you're simply finding is the acceleration, which is, remember we said acceleration is change in velocity over the change in what? Over the change in time. So this change in velocity is actually to the given velocities. As you can see, this is the first part of the velocity, which corresponds with 30, and the last one, which corresponds with that, with 50, like that. So using just normal numbers, guys, we can just write this as the final velocity minus the initial, like this. So remember, V is for final, U is initial, like this, over the change in time. So you can just write T2 minus T1, like this. Okay, so you can substitute now into the formula. So the final velocity in this case, as you can see, we are talking about from this point up to this point. So this is the velocity that corresponds. Remember, velocity is on this axis. So at 50, the velocity is 0. So we are going to have 0 minus U, which is the initial, where it started to decelerate. It started at this point to decelerate. What was the velocity at this point? It was 25. This point corresponds with what? With 25. So it's going to be 0 minus 25 over, we do the same in terms of time. When we started at 25, this was the time, and ended at 50. So it's going to be 50 minus what? Minus 30. Final minus initial. So this is final minus initial. So it's 50 minus 30. So that is what you're going to have in this case. So simplifying this, you can actually use your calculator in this case. That's 0 minus 25 over 50 minus 30. Okay, so we just put a fraction like this. That's 0 minus 25 over this is 50 minus 30. Okay, that's 50 minus 30 there. So make sure that you simplify this properly. You must obtain something like minus 1,25, or you can write it as a fraction depending with the way that is best for you. So as we say that this is going to be negative acceleration, which is measured in meters per square second like this. So as you can note, this is the deceleration in terms of the negative. It's actually a negative answer that you're obtaining, but you can actually write this as the deceleration, which is equal to 1,25 meters per square second, since it is negative of the acceleration that you're going to obtain. Or you can just write as a negative like that, still it's fine. Okay, so that is what we have on the deceleration. Then the other part is the total displacement of the train. Okay, the total displacement, remember total displacement is equivalent to the area that is under the graph that you're given. Okay, so that is a total displacement, which is S total is equivalent to total area under the graph. Okay, so we're going to calculate the area. So what do we have in this case? If we are to cross check, we have two things. We have this part here, which is a rectangle and a triangle. So that is the two things that we're going to have. So we have the area of a rectangle from the rectangle plus the one of a what? Of a triangle. Okay, so let's add these. So from the rectangle, remember our area is length times the breadth. So we have from this point to this point, that is 30. From this point to this point, that is 50. These are the dimensions of the rectangle. Length times width. So it's 30 times 25. Okay, just take these as they are. 30 times 25. Plus, we move on to the triangle. Remember, area of a rectangle, a right angle triangle is half base times what? Perpendicular height. So it's going to be half multiplied by the base, which is from 30 to 50. This is the triangle that you're talking about. So this is the base here from 30 to 50, which means you're going to subtract 50 minus 30. So from your calculator, you're going to obtain 20 in this case, multiplied by the height, that is from this point to this point. This is the height of the triangle, this one. From this point up to this point, as you can see, it corresponds from this point up to 25. So this is going to be the height there of 25. So you combine everything so that you can find the total area. So using the calculator in this case, let's see what you are going to obtain. That's 30 by 25, which is something like 30 by 25. Okay, by 25 like this, which is going to be 750. So this is 750. Plus we combine these two, that is half of 20 by 25. Okay, that is 1 over 2 by 20, then by 25. Is that so? If I'm not mistaken, yes, that's 20 and 25, which is going to give us something like 250. So you have 250 in this case. So combine the two. What are you going to have? This one plus 200 plus 750. Remember the first part was 750. Okay, so it's going to be 1000. So the distance or the displacement in this case is going to be 1000 meters. We have a total of 1000 meters from that part that we are given. So this is 1.22. That is what we had from this part. Okay, let's see the other part. We are asked to calculate, determine the average velocity of the train. Okay, so average velocity, this is the formula that you're going to have for average velocity. This is 1.23. So the average velocity in this case is actually the total displacement over the total time. So that is what you're having in this case over the total time taken. So in this case, the total time taken is 50. From this point to this point, it's 50. And the total displacement from what we calculated here, this is S total, okay, which is 1000. So it's going to be 1000 over the total time, which we said the total time is 50 according to the diagram that we are given. So if you divide this properly, guys, you must obtain, okay, let's just do this together. Divide by 50, I'm going to obtain 20. So that is going to be average velocity of 20. Remember, velocity is 20 meters per second, or you can just write as 20 meters per second like this. It's one and the same thing. So that is what you are having there on the average velocity. So this can be also be referred to as the average speed in some way. Okay, the maximum deceleration of a car is 15 meters per square second. Okay, we are given the deceleration in this case, which is 15 meters per square second. Okay, so let me write it this way. Remember, from the last question that we did, we calculated deceleration. I want you to see this part properly. When we calculated deceleration, we obtained a negative value in terms of what? In terms of the acceleration. So it is the same thing that you're going to do in this case. You are given deceleration, but you're going to write it as the acceleration. So as acceleration, it means this is going to be minus 15. We are given a deceleration of 15 meters per square second, but as acceleration is going to be minus 15 meters per square second like this. Okay, then what else are we given? We are given that if the car is traveling at, this car is traveling at 200 kilometers per hour, so this is the speed or the velocity that you are given in this case. Okay, so you can just write this as the velocity, which is 200 kilometers per hour. But we have the velocity in this case of 200 kilometers per hour, but depending with the situation that you are given, because here we are given that if the car is traveling at, so which means actually this is the initial velocity that you are given from the point that we have in this case. But we have to change also this velocity that we have to meters per second. Okay, so this is our u. So how do we convert this? We have 1 meter per second from our conversion on our formula sheet, which is equivalent to 3.6 kilometers per hour. Okay, so if 1 meter per second gives us 3.6 kilometers per hour, what about 200, which means we're going to divide by 3.6. What we are just writing like this. This is 200 kilometers per hour. So using simple proportion, this is what we need here, which is going to be more. So it's 200 over this value times 1 meter per second. So if you divide this, what are you going to obtain? That's 200 divided by 3.6. Okay, so we are going to obtain something like 55,555 like that. Okay, so you can just round off maybe to 3 decimal places. This is going to be 55,556, something like this, meters per second. Okay, because you're supposed to write this in meters per second. Then let's see what else are we given. The question is on 1.31, calculate the time it will take for the car to come to rest. Calculate the time, okay, for the car to come to rest. So take note, at rest, it means the final velocity is 0. Okay, so our final velocity v is 0 meters per second. So what is the time? You need the time. So taking this information to calculate 1.31, where we need the time, so we have the acceleration, we have the initial velocity, we have the final velocity, and we want to calculate the value of what? The value of t. So using these formulas from your formula sheet, you're going to have these formulas here. So we have this Vs is equal to this formula, we have V, we have this one again. So which one of these is the best formula? So as you can see, we can choose this one. V is equal to u plus at. Okay, so let's just take this and see what we are going to have. If v is equal to u plus at like this, let's make t the subject therefore, or you can just substitute information here. Our v is 0 in this case, which is equal to u, which is 55,55 plus 80, but remember our a in this case is minus 15. That one that we talked about, it's a deceleration, so it's going to be taken as negative, so it's negative 15t. So let's calculate the value for t. It's going to be 55 to this side. We're going to subtract 0 minus 55, 555, it was now 556, okay, which is equal to negative 15t, like this. So this one you subtract, then the answer you're going to divide by negative 15 by negative 15, okay. So that means our t is going to be, we divide this from our calculator, so that's so I can just store this, I can just work with this like this, okay. That's 0 minus the, okay, what am I doing here? That's a fraction, and then we have 0 minus, sorry, I'm not putting the fraction, let me just put a fraction like this. That's 0 minus the answer that we obtained. Now I'm not sure if this answer is still correct because of that error that it wrote, but let's just write as it is. It was 55,5556 over minus 15. So take note, this is minus 15 here, so you're going to divide by negative 15 like that. So you just use your calculator properly, okay. So this is what you're going to obtain, which is 3,7037. So this can change this one to 4, which is going to be 3,704 seconds. So the time is going to be in seconds. So this is the time that we are obtaining from the information that we had. Okay, so let's see the other question, what we were given to find. This is the absolute minimum distance needed for the car to stop. Okay, so we need the distance here, the minimum distance that can be taken, which is s. So from the information that we had from our formula sheet, again you choose the best formula. Now you have the value for t, so you can choose any of these formulas. So you can even use this one, as you can see, this one is direct here. Okay, so let's use that formula. So it states that s is equal to, so there are two formulas with s. There's this one, s is equal to ut plus half a t squared, half a t squared, like this. Then there's this one with the v squared is equal to u squared plus 2as. So I can use this one and make s to be the subject, or I can even use this one, okay. So let's just use the first one. S is equal to ut. So remember, from our information, we now have the t. U is the initial velocity, this one, which was 55,556. Okay, we are using this multiplied by the time, which is 3,704. 3,704. Okay, this is what we have, plus half a t squared, which is half times a. Remember, our a is negative 15, so it's going to be negative 15 by t squared, which is this value here of t. So it's 3,704 squared, like this. Okay, so applying the calculator properly in this case, we must obtain something like 102 there. So I just want you to use your calculator, something like that, which is in meters. So this is going to be the minimum distance that can be traveled for this one. So you just choose between the two formulas which one is your best, but using this formula or using the other formula, you are supposed to obtain something like this. So make sure that you just apply your calculator properly. So as you can see, guys, when you are working with dynamics, it's about understanding of the given information that you have. You must understand well the information, the units. How do you represent the units? Definitions, proper definitions, proper units, proper formulas, and this can help you a lot. Okay, so that's what we had on this question. We shall meet again another episode, still working on engineering science for N2 level engineering, for netted engineering. So that's it, guys, from Mason African Motives. Till we meet again.